We are in chapter 2. Chapter 2 talks about kinematics in 1D motion, one dimensional motion. That means kinematics is equivalent to kinetics, you can say. So, that means we are looking at a body or a particle moving along one dimension. It could be x direction or it could be a y direction. In the last chapter 1 about the concept of motion, we learned about 2D plots about x and t plot, which gives an average velocity, or the v and t plot, which gives an acceleration. So, we have seen that the linear plot provided that average velocity of a position versus time, and the linear plot of a v versus t gives an acceleration. We have seen that. So, keep that in mind, that those are very important for us to understand the kinematics. Kinematics is why it is important, or what is it? It is nothing but a mathematical description of a motion. Let us say I have an equation which I got from the previous chapter. The velocity average is x final minus x initial over delta t. Sometimes in physics and math, we try to linearize and write the equation in linear fashion. So, I can manipulate that equation so that I can write x final is equal to x initial plus Vs or Vx delta t. I am going to start with the displacement or the position in the letter S, because in your book it says S. S is nothing but a position coordinate, it could be x or y. So, I tell you this linear equation again. S final is equal to S initial plus Vs delta t. That is my first equation. Look at that equation. S final is my final position, S initial is my initial position. What is that next is Vs delta t. Now, Vs delta t is my focus. Why? I try to plot a graph between V on the y axis and delta t or t on the x axis. I can get a curve or I can get a linear plot. That tells the story about the calculus. Why in physics, why are we dealing with the calculus? Because calculus provides us a facility that it gives a derivative of something, some function. So, when I plot a graph between x, x on the y axis and t on the x axis, I get a plot. It could be a linear or probably any curve shaped plot. If I get the area under the curve, that is why we are taking the help of a calculus, because if I find the area under the curve, that itself tells about what is the relation between V and delta t. So, my equation will be S final is equal to S I plus area under the curve of Vs versus delta t. Or sometimes you are looking at the instantaneous position, instantaneous velocity, then my derivative can be changed to integration. So, at delta t is turned to 0. So, my equation will be Sf is equal to Si plus you have to integrate t initial to t final, integrate the Vs, that is the velocity S, times delta t or dt. So, I have to take a help of a calculus and the integration calculus to work on either area under the curve or integration within the boundary of Ti and Tf. I can get the parameter that is called Vs delta t. So, that is about the story of x and t. Now, I am going to talk about, okay, now I got a velocity and time curve. Velocity on the y axis, delta t on the x axis. I can plot a graph, it could be a linear plot. From linear plot, I can say if linear plot is constant, my velocity is constant, therefore, my acceleration is 0. If my velocity is constant in the positive axis, I can also get my acceleration, which is 0 above the 0 line. So, I can, from this plot, I can get a value that is A, acceleration is delta V divided by delta T, or A is V final minus V initial over delta T. As a physicist or an engineer, I want everything to be linearized fashion, so that I can write V final is equal to V initial plus A delta T. All right. So, V final is my final velocity from the linear plot, V initial is initial velocity from the linear plot, plus A is your acceleration vector, which you get from the slope, and delta T is your time factor. So, I can generate two kinematic equations. One I said earlier, S final is S initial plus Vs delta T. The second kinematic equation is V final is equal to V initial plus A delta T. Okay. I am going to talk about the third kinematic equation, little complex, but still that is easy to understand. All right. I am plotting a graph between V on the y axis and delta T on the x axis. I get a linear plot. My initial velocity is not a 0. I am already in some velocities like Vis. At a Ti or T initial, I am on the velocity Vis. For example, at 5 seconds, I am a velocity at 10 meters a second. Then on the same curve, I look at my final velocity at T final could be 20 meters a second. So, I go from initial velocity to final velocity. That also you can fit it in the position equation. As I said, position equation is S final is Si plus Vs delta T. Now, we are going to look at the Vs delta T. The Vs delta T, where you can get the area under the curve. Area has two combinations. One is a triangular area and rectangular area. If you get the triangular area by 1/2 BH and rectangular area by A times B, you can get that area, total area. Therefore, my final equation of the third kinematic equation is Sf is equal to Si plus Vs delta T plus 1/2 As delta T square. Again, the 1/2 As delta T square is 1/2 BH, that is triangular area. Vs delta T is your rectangular area. Therefore, your final equation for the third kinematic is Sf is equal to Si plus Vs delta T plus 1/2 As delta T square. Now, the final fourth equation is simple substitution. I do not want to derive it, but I can give you the equation V final square S is equal to V initial square S plus 2 As delta S. V final square is final velocity, V initial square is initial velocity square plus 2 times acceleration times my change in position, that is delta S. You may ask, why do I need 4 kinematic equations to solve the problems? The first kinematic equation, as I said, that is the relation between my initial final position and the velocity with respect to time. The second equation which I showed you, the relation between velocity initial and velocity final with the relation of acceleration and the time. The third equation is you can relate displacement, that is delta S, with the initial velocity and the initial acceleration. The fourth one is velocity and acceleration with delta S. So, 4 different equations will be used to solve different type of problems. Again, you do not need to memorize it, but you understand the concepts that is good for us to solve a problem on any of the motion. It could be x motion or the y motion. Then we can solve by pick up the right equation is a challenging part, but once you understand that, it's a piece of cake. You can work it out. Thank you.